Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, this is your instructor Aisha Hussain Khan. Today we will start with chapter 2, that is on process models, and the book name is Software Engineering, a Practitioner's Approach by Roger S. Pressman. So students, before moving to current topic, we first see the summary of the previous lecture where we have covered the intro to software engineering, in which we seen the different aspects of software and hardware. Also, we covered the definitions of software engineering field. Secondly, we have seen the software application domains. There are essentially many domains, like we have web apps, we have artificial intelligence domain, product line softwares are there, system softwares. So we have seen various domains, and after that we see the concept of legacy softwares, which are basically the old softwares that needs enhancements and extensibility to maintain or to cope with the current needs of the business. Finally, we seen the software process. Whole software development life cycle process was discussed, in which we started from requirement gathering till the deployment phase. This slide is presenting an outline of today's lecture. We'll first cover a topic on a generic process model. Then we'll see what are process flows. Thirdly, we will find out what is a task set and how we can identify a task set. Then we learn about the process patterns and the different types of process patterns. Then process assessment and improvement is discussed, and finally we will deal with prescriptive process models, and we'll cover different process models inside this topic. So starting with our first topic, that is on a generic process model, we can see here is a pictorial representation for a software process. Let us know the hierarchy given in this diagram. First, we have a software process model window. Inside that process, we have process framework, and process framework is further decomposed into umbrella activities, various umbrella activities you can say, and each activity is being allocated a significant number, framework activity 1, and inside that activity we have various actions, and we have also numbered those actions to take an account of it. And these actions are basically presented in a form of a task set. So the smallest smallest element is a task set that is present inside an action, and a task set is further composed of work task, that is the objectives of your project, and then we have work product, that are the outcomes of different activities. Then we have quality assurance points, and finally we have project milestones. So this task set is accomplished in a single action, and further you can go on to different actions and while reaching to the last activity and its basic last task set. So coming to our second topic, that is on process flow, we can say that we have 4 basic process flows available. First is a linear flow, second one is iterative flow, the third is evolutionary flow, and the fourth one is parallel flow. So coming to the first one, we can see that we have communication flow, and then that is ending up at deployment phase. So you can see that it is a sequential flow or a unidirectional flow. It is not letting you move in a backward direction in any case. And the second flow, that is iterative flow, is giving you the perspective of repetition. Like when you are in planning phase, if there are some changes that are required in a communication phase, then you can move back to the communication phase. And likewise, in any activity, if you feel like moving to the previous phase, you can move back in the iterative flow. Here comes the concept of repetition that plays a very important role in software development cycle as the requirements keep on changing. Now thirdly, we have an evolutionary process flow. Here you can see that it is in the form of a closed cycle, starting from communication and ending up again at communication for the next iteration to proceed. Here is the fine distinction between the iterative flow and the evolutionary flow. In this cycle, we have a complete phases of all the activities done, and then we start from the communication activity again. Like if you remember that in iterative, we can switch from any activity to the previous one and then we can execute in the similar fashion. But here in evolutionary flow, you have to proceed through a whole cycle, and then starting from the communication, you again will start a next iteration. Here basically the changes are allowed as well, like in iterative flow, but you need to go in a complete cycle. The last one is parallel process flow. In this flow, you can see that we can have different activities residing at the same time. Like in parallel to communication, you have a planning phase. You can concurrently execute these two activities. After that, we have modeling phase, and then finally construction phase ends up in deployment phase. So here we can see that communication and planning executes simultaneously. So likewise, this can result in, basically you can say that planning and modeling sometimes can be done in parallel. So this will reduce the time to implement or to develop the product, and this will result in efficiency. Starting with our third topic of today's lecture, that is identifying a task set. A task set is basically, it gives you the actual work to be done to accomplish the objectives of the software engineering action. Like what features you want to build or what functionalities you need to accomplish comes all in the task set. It encapsulates a list of the tasks to be accomplished, and secondly we can say that a list of the work products to be produced, final outcomes, and a list of the quality assurance filters to be applied. Process patterns. What is basically a process pattern? That it will provide you a solution to the problem, and this problem can be emerged at any stage during the software development cycle. Like the problem could be of design phase or development phase. So it basically targets to provide you a template that is serving a solution to that particular problem. So here is the formal definition for it, that it describes a process related problem that is encountered during software engineering work, and it first identifies the environment in which the problem has been encountered. Like it's the implementation environment or design environment, what type of problem it is. First it finds the environment, and then it suggests one or more proven solutions, or you can say a solution template to that problem. We can see that in more general terms, a process pattern provides you with a template, and it is a consistent method for describing a problem solutions, as it is giving you the same solution every time. So you can say that it is a consistent method and within the context of the software process. So in general, to a problem, process pattern provides you with a solution. Now, process pattern types. We have 3 different types for a process pattern. First is stage pattern. Secondly, we have task patterns. And thirdly, we have phase patterns. These 3 different patterns are providing you a solution at the different levels during the software development cycle. Initially, stage pattern is defining a problem that is associated with a framework activity, with the complete framework activity. Like we have 5 basic framework activities: communication, planning, designing, and construction, finally deployment. So among these activities, stage pattern find out the problem that is associated with a particular activity, and then it will give you the solution for it. And then we have task pattern. It defines a problem that is associated with the software engineering action, or you can say the task pattern is related to a task set that we have studied under the framework activity. Phase pattern defines the sequence of framework activities that occur within the process, even when the overall flow of activities is iterative in nature. Like it is governing all the framework activities, and the nature of activities can be iterative. Now coming to the 4th topic, that is on process assessment and improvement. We can see that the existing of a software process is basically giving you no guarantee that the software will be delivered on time, that it will meet the customer's need, or you can say that it will exhibit the technical characteristics that will lead a long-term quality characteristics. So along with the software process and process patterns, there should be some techniques that should be opted to guarantee the quality measures. And so a number of different approaches are basically to software process assessment and improvement have been proposed over the few past decades, that are standard CMMI assessment method for process improvement. In short, you can say that SCAMPI provides a 5-step process assessment model that incorporates 5 phases. Basically, this model is directing you towards these 5 phases, and initiating, diagnosing, establishing, acting, and learning. Again, another standard is CMM based appraisal for internal process improvement. Short is CBA-IPI. Provides a diagnostic technique for assessing the relative maturity of software organization. Maturity means how many levels your organization have crossed. So there are some maturity levels to claim that we basically are having the highest quality at this level. Uses a SEI CMMI as the basis of assessment. Then we have SPICE, the SPICE ISO IEC 15504 standard defines a requirement for software process assessment, and the intent of the standard to assist basically organizations in developing an objective of the defined software. And the last standard is ISO 9001 2000 for software. This is a generic standard that applies to any organization that wants to improve the overall quality of the product, system, or service that it provides. Therefore, the standard is directly applicable to software organization and companies. So these are basically different standards that must be acquired by the organization to ensure the process improvement at their organization. Now the last major topic is on prescriptive models. Prescriptive is basically telling you the steps to do the software development process, and there are basically the different approaches to carry out the software process, which we term as the category of process models. So starting with this, we can see that prescriptive process models provide you an orderly approach to software engineering, and that leads to basically few questions that can emerge in one's mind. That is, if prescriptive process models strive for structure and order, are they appropriate for the software? Would that thrive on change? Basically, change in requirements matter. So, yet, if we reject traditional process models and the order they employ and replace them with something less structured that has no proper rules, you can say, do we make it impossible to achieve coordination and coherence in software work? So these are two visions. Like, we can think of a change in the requirements, and also we can think that if we are not basically proposing an structured approach, so what should be the basic solution to these questions? We will answer these in the coming slides, as we will study different models according to the different rules they are providing. So starting with the traditional models that are available, we first learn about waterfall model, that is a basic model and follows a linear approach. As we can see, starting from communication and ending up at deployment. So we are heading in a forward direction, and we can see that we are not moving in backward in any case. So communication activity basically handles project initiation and requirement gathering, and then planning basically focuses on estimation of cost, scheduling of time, and tracking the progress. Then we have modeling, where we do analysis phase first and then we cover the design phase. Basically, analysis provides you a way to more structured and formal diagrams that we cover in design phase. And construction focuses on code and test. We can see that we need to code and then remove the bugs and make it defect free. So we put the code and test in construction phase alongside. And then we have deployment, where we provide delivery and support feedback mechanism. So we can say that in this case we can't handle requirement change as easily required, as we can't move in the backward flow. So this always make you progress forward. Waterfall model is a linear followed approach. The V model. This is basically the variant of waterfall model, and we can see that it is structured as just the alphabet V, and see that at moving from the left side to the bottom direction, these are the general steps that are involved in the software development: requirement modeling, architectural design, the component design, and the code generation. And then moving up in the right direction, we are basically adding the quality assurance checks along the different phases we have acquired during the first half. So when we started moving to the left side, we see that we perform unit testing on these two phases or activities. Then we perform integration testing, that is another level of testing that is performed on these aspects. And then finally we do system testing and acceptance testing that are basically required to validate or verify the customer requirements. So in this variant, we are basically adding the quality assurance points to the simple waterfall we have learned in our last section. Now the third model is the incremental model. Basically, there are many situations in which the initial software requirements are reasonably well defined, but the overall scope of the development effort does not support a pure linear process. And in addition, there may be a compelling need to provide a limited set of software functionality to users quickly, and then refine and expand on that functionality in later software release. So we can say that we will build our product in different number of releases, and these releases are termed as increments. Like you can see here that increment 1, then we have an increment 2 leading to the final increment that we have generically termed as increment n. So these are the short releases, and you can show the end product to the user for the requirement conformance, or you can say acceptance testing. And this is the first delivery, then we have another short delivery, and then the nth or final delivery of the product, that is the final release of the product. This is basically helpful when the requirements are not fully gained, and with the passage of time we are adding more and more of the requirements to refine our product. So this model prefers the requirements at later stages, and then we can add it on the previous one, so we can extend our model. Like we can increase the model functionality wise. Finally, we have evolutionary models of two different paradigms. First is evolutionary models in which we will discuss prototyping, and Then we will discuss the spiral model. Both of the models come in the category of evolutionary model. Evolutionary models, as by name indicating that they are following the evolutionary process flow. Like you can see here that the software development cycle proceeds in a form of a closed circle, starting with the communication, and then for the next release again it starts from the same start point. So we have here the aspect of prototyping as well, that it will turn the final product in different releases, and this is what we call that prototyping, that initially we will make the core product and then adding new requirements we will go through the cycle again and again. Prototyping always results in a quick plan, quick design, then quickly you code and test that initial set of requirements and then deploy for delivery and feedback support. So this process will further continue until the final release or the most final version is accomplished. And prototyping models or evolutionary models are best utilized for complex softwares where the instructions initially are not fully set. So with the passage of time, we will add more specifications and come up with the final versions of our product. Now finally, the spiral model that was originally proposed by Barry Boehm. The spiral model is an evolutionary model, and you can say that it couples the iterative nature of prototyping and with the controlled and systematic approach of the waterfall model. Like it is a combination of the prototyping and waterfall model characteristics. It provides the potential for rapid development of increasingly more complete versions of the software. The spiral model, as you can see here, basically divides the framework activities in different segments. Like here, first segment is showing you communication, then we have planning, estimation, scheduling and risk analysis that are included basically in a planning phase. Then we have modeling phase and construction, and logically we have final deployment phase. So we can see here that it is formulating a spiral and that is segmented according to the different framework activities, and these the starting points basically indicates the anchor point milestones, or these basically objectify your features and functions that have been accomplished, and further in the next cycle we keep on adding other functionalities to make the complete version of our product. So further we will discuss the applications related to each and every process model in our interactive session, and till then, thank you.